Okay, to solve questions 21 and 30, we need to go back and we need to take a look at our theorems. When you look at 21, what we have is we have a length of the leg of the largest right triangle, triangle JKL, and we're looking for the hypotenuse JK. Well, the theorem says that the length of each leg of the right triangle, so in this case 32, says the length of each leg of the right triangle is a geometric mean. When simplified, means the square root of the product of these two numbers, and the two numbers are the length of the hypotenuse, which in this case is JK, which we don't know, which we could call X, and the segment of the hypotenuse that's adjacent to that particular leg. The segment of the hypotenuse adjacent to 32 is 15, so that's JK times 15. So 32 equals the square root of 15 JK. To get rid of the square root, we do the opposite. We square it. We square 32. When we square 32, we get 1024. Here, the square cancels out the square root, leaving us just 15 JK. When we divide by 15, JK is equal to 68.26, with the 6 repeating as a fraction in reduced form. That is 1024 divided by 15. So either way would be fine. But that's how you solve JK. Now for 30, we're going to do a lot of the same thing, but instead of having a leg here, we have the altitude. And the theorem above that, theorem 9.2, says in a right triangle, the altitude, which we have drawn from the right angle to the hypotenuse, divides this hypotenuse into two segments, which are 8 and 18. And it says the length of the altitude, which is x plus 9, is the geometric mean, which again is the square root of the product of the lengths of the two segments. The two segments being 8 and 18. So x plus 9 equals the square root of 144. So x plus 9 equals 12. Subtract 9 from each side, and x is equal to 3. And that is how you solve questions 21 and 30 from the geometry.